G'day, Mr. Bennett here. Today we're going to be looking at the quotient rule, okay? And it's very similar to the product rule. Now, with the product rule, you would have found that it didn't really matter which one you picked as your F and G. In this particular case, what we have to do is we have to make sure that we pick our top function to be our F function and our bottom function to be our G function. Now, if you don't do that right, you'll get the wrong answer, all right? So, again, we're going to break into simple steps using our side calculations, and what you can do is you can show these side calculations, but again, down the track I will be expecting that you'll be able to do this without having to write these down. But while you're learning, I think it's worthwhile doing it. So if that's my f function there, my f dashed is going to be equal to, well, it's not going to be 3x, it's going to be equal to 2 times by 3, and that will become equal to 6x, won't it? The top line. The bottom line, my g dashed, is going to become equal to, well, that's x plus 2 to the power of half, so that's going to be a half, x plus 2 to the negative a half, times by 1. Alright, so keeping that in mind, that calculation, so when I start doing my dy dx, okay, it's going to be my f dashed. My f dash is going to be 6x times by my g. My g is simply x plus 2. And then I've got to go take. Okay, so it's take f. Now my f function is 3x squared times by my g dashed. Okay, that's going to be simply a half x plus 2 to the minus a half. Now I suggest probably not simplifying this thing as you're going, and then that's all over g squared. Okay, so that's going to be all over root x plus 2 squared. So I can write that if I wanted to, but I know x plus 2, when I square that, it's going to give me simply x plus 2. Alright, so that's the answer for the first question. Right, over here, okay, what we'd be saying here is if my f is equal to x squared plus 2x to the power of 5, then my f dashed is going to be equal to 5x squared plus 2x power of 4 times by 2x plus 2. So that's a differentiation using the function of a function rule. Then the bottom line, my g is equal to 3x. So my g dashed is going to be equal to 3. Alright, so again I'm going to use the quotient rule. And when you're doing this, by the way, you should be stating which rule you're using. But because we're just learning it, we won't worry about doing it now. So that's equal to, I might need to add a little bit more space down the bottom actually. So we'll do that. So dy dx, excuse my messy writing, that's going to be f dash, which is 5x squared plus 2x to the power of 4 times by 2x plus 2. Now that's simply f dashed times by g. Now g is 3x. Take away f, which is equal to x squared plus 2x to the power of 5 times by g dashed 3, and that's all over g squared. So when we square that, it's going to be 3x squared, so that becomes equal to 9x squared. Done, finished. Alright, so again you need to highlight the fact that you've got your f dashed, that's all my f dashed. Okay, then I've got my g, then I have my f of x, and then I have my g dashed. Alright, so you can see what we're doing there with all of these things here. We're just using the rule, and what we're doing is simplifying it by making sure that we're breaking into one-step problems rather than having it all done. Now, what I'd like you to be able to do is get to the point where if you got given something, let's say we're given y is equal to, what could it be, 6x squared all over 2x plus 1 cubed. Then I would be expecting that you could do this in one line eventually without using the rules. So f dashed, which will be 12x times by g, which is 2x plus 1 cubed. Take f of x, which would be 12x. Oh, sorry. Hang on, I'm not differentiating, am I? That's going to be 6x squared times by g dash, which is going to be, now I have to use my function of a functional there, so it's going to be 2x plus 1 squared times by 2, and then that's all over this thing over here, the g squared, 2x plus 1 to the power of 3 squared. And when we do that, that becomes to the power of 6, doesn't it? Alright, so that's where you need to get to. Okay, now the reason why you have to get to this particular point is when we're differentiating, once you've done a lot of differentiation, you need to be able to do it quickly. In the exam, if you could do that quickly, because they would probably give you, for something like this, probably 3 marks. If that takes you 3 minutes, well, that's probably working about the right standard. But if you could do that in a minute, then you've got 2 marks to work on a question that may be a little bit harder. So we want to get good at doing this, and the way you get good at doing it is by practicing. All right, so that's what you need to do, is keep practicing, getting good at this, using the rules, getting good at differentiation. Again, it's just a process. It's nothing that's really asking you to use any brain power apart from just learning a process and applying some rules. So good luck with those. Work through them. Make sure you do enough of them till you get to the point where you go, this is really easy. All right. So, and I'll talk to you in class about that.